Hi, and welcome to another lesson. This one is about what is an acid. Now, we've just started this topic on acids, and it's most important we have some idea of what it really means for something to be called an acid, and we'll also quickly look at what it means to be called a base. So if we were going to define an acid or come together and put some meaning to it, we could come up with this sort of idea that it's something that causes an indicator to change colour. Now, I think it's aptly named an indicator because it does indicate if something is present or absent, and most importantly, I suppose, it allows us to quickly see if something is there, but unfortunately it doesn't let us know how much is there. But bases also do that, so maybe we need to go further into this. If we think of the idea of what an acid is, and most of the acids we find at home are in the foods we eat, things that are really, really spicy and sharp to the taste, we might even call it bitter, things like lemons, other citrus fruits, onions have acid in them. That's what makes you cry, because you get onion fumes in your eye, and it works from there. Chilies, believe it or not, also have acid. So we could say, all right, if we were able to eat it, then we'd find it's bitter. Acids also let electricity or charge go through them. And this is why the car battery uses sulfuric acid as its electrolyte. Now, the electrolyte is simply the solution or the liquid that lets charge go through it. But I still don't think we've quite got enough. So how about we talk about it in terms of chemistry? And we're going to introduce a few terms here and a few ideas. We all know about matter is being made of atoms. But sometimes atoms can gain or lose electrons and take on a charge. When this happens, we don't call them atoms anymore, because atoms by definition don't have a charge on them. Now, since they are charged, we call them ions. And we're going to say, for the sake of our exam and for the sake of all the things we do in this topic, that acids are chemicals that form hydrogen ions, especially when they dissolve in water. And this will change as you go through and deepen your studies of chemistry. For those who go on and do chemistry in the diploma program, it will change. But for our purposes, this is what we are going to say is happening. So obviously, the more hydrogen ions that an acid is able to form, then we could say it is stronger. Now, strength is used in a very specific way in terms of acids, and it talks about the number of hydrogen ions formed. You will also be given another term called concentration, which tells us how much acid is there and how much water has been added to the acid, or if it's been diluted. The scale that helps us out here is the pH scale, and that's the one we've been learning about and we'll be spending more time with. And we're going to say two things are true for acids. First thing, pH scale measures H+ concentration, or hydrogen ion, the amount of hydrogen ions that are present. And so the greater the number of hydrogen ions, or the greater hydrogen ion concentration, the stronger the acid. And then from that, let's relate it to the pH table. So we could say the stronger the acid, the lower the pH value. Remember, acids have a pH value less than 7. So right down near 1s and 2s maybe, we are in the realm of strong acids. We are dealing with opposites here. It's like yin and yang. Acids are one, bases are the opposite. Bases also change the colour of an indicator. And they also let charge move through them. So some bases are also electrolytes, but only those bases that will dissolve in water. And we give them a special name. The name we give them is called alkali. So alkalis are the small group of bases that will dissolve in water, and they're the ones that will let charge move through them. So they are electrolytes again. We are going to distinguish acids though and bases, and we're going to say that bases also help form ions in when they dissolve, and the ion they form though is not the hydrogen ion, it's the hydroxide ion. Now if you look very carefully, there's a difference between those two. The hydrogen ion only has H, hydroxide has the oxygen as well, O for oxygen, H for hydrogen. The hydroxide ion, the hydrogen ion, was positively charged. The hydroxide ion is negatively charged, and this becomes really important when they react together, because we all know that opposite charges attract each other. So it might have something to do with their reaction later on. We'll go into that in another of our videos we're going to be watching. And on that note, I'm going to leave it. I'd like you to try to make sure you have enough good information in your books to study from this too.